Hello friends, in the last video we have solved question number 6. Now we are starting question number 7. Such type of example even you have solved in your earlier classes also, means up to 10th standard in geometry. But now we are solving the same examples, but you instead of using geometrical method, here we have to solve this example using vector method. Getting it? So now we have to prove that a quadrilateral is a parallelogram if and only if its diagonal bisect each other. This is nothing but one of the theorem. I think you have studied it in 9th standard, that if a quadrilateral is a parallelogram, then diagonal bisect each other, or if diagonal bisect each other, then quadrilateral is what? Parallelogram. But at that time we have applied which method? Geometrical method. Here in the examination, question can be asked that using vector method prove this thing. Means here we have to apply vector method to prove this statement. Here two parts are connected by if and only if. Whenever two parts are connected by if and only if, at that time we have to consider first part as a given condition, then prove the second. Then consider second part as a given condition and prove the first. Means here we have to prove the converse part also. Well, first now we are considering that first part as the given condition, that a quadrilateral is a parallelogram, and using this we are trying to show that its diagonal bisect each other. Well, so now here we have considered one quadrilateral ABCD which is parallelogram. So we are considering first as a given condition, quadrilateral ABCD is parallelogram. Hope all of you know that parallelogram symbolically denoted by this notation also. Now, to use the vector method, we have to define what? Position vector. So define the position vector of this vertex A, B, C and D. So let A bar, B bar, C bar, D bar be the position vectors of points A, B, C and D respectively. Isn't it? So after defining this position vector, can I say that here AB bar is equal to DC bar? So AB bar is equals to DC bar. So we are saying that these two vector quantities are equal. And when we can say that two vector quantities are equal, if their magnitudes are equal, check whether magnitude means length of AB and DC are equal or not. AB and DC are nothing but what? Opposite sides of parallelogram. And we know that opposite sides of parallelogram are equal, means their lengths are equal. So that's why in terms of vector we can say that magnitudes are equal. Now we have to check whether their directions are same or not. We know that opposite sides of parallelogram are what? Parallel also. If the opposite sides are parallel, means we can say that directions are same. So directions are same and lengths are equal, means magnitude are equal. That's why we can say that these two vector quantities are equal. Give the reason here. These are opposite sides of parallelogram, and since it is opposite sides of parallelogram, means their magnitudes are also equal and directions are also same. That's why we can say that these vector quantities are equal. We know that this AB bar in terms of position vector can be expressed as B bar minus A bar, and DC bar can be expressed as what? C bar minus D bar. So just we are converting this vector in terms of their position vector. Now we have our required result is in terms of what? Diagonal. We have to prove that diagonal bisect each other. Which is the first diagonal? AC, and second diagonal is BD here. So one diagonal is AC and second diagonal is nothing but what? BD. So these are our two diagonal here, and we have to prove that this diagonal bisect each other. So first diagonal is AC. So collect the term of A bar and C bar on one side, and second diagonal is what? BD. So collect the terms of B bar and D bar on another side. So this minus A bar on this side will become plus A bar. Keep plus C bar as it is. So we have collected the terms of A bar and C bar on one side. Another side, collect the terms of B bar and D bar. So here keep this B bar as it is. Minus D bar on this side will become plus D bar. Okay. So now we have collected term of A bar, C bar on one side and B bar and D bar on another side. Since AC is one diagonal and BD is second diagonal. Now I am dividing both sides by 2. So B bar plus D bar upon 2 is equals to A bar plus C bar upon 2. Just simply I am dividing both sides by 2. Now this is also the vector quantity. This is also the vector quantity. Their value is nothing but new vector. Let us denote the new vector say by E bar. And I am seeing that here where E bar is position vector of of some point say E. So we are E bar is position. It is the value of this vector will be another vector. That vector we are denoting by what? E bar. And E bar is definitely position vector of some point. I am supposing that it is the position vector of point E. Now, if we are considering first value of E bar, what is first value of E bar? B bar plus D bar upon 2. Such type of result we are getting applying what? Midpoint formula. So here what is our conclusion? If we are considering E bar is equal to B bar plus D bar upon 2, means E is the midpoint of which segment? BD, applying midpoint formula. If we are considering second value of E bar, what is second value of E bar? A bar plus C bar upon 2. Here what is our conclusion then? According to midpoint formula, is the midpoint of what? AC. So therefore by midpoint formula, let us see what we will get. Formula, if we are considering first value of E is BD, means E is the midpoint of BD and even E is midpoint of AC. By midpoint formula we can say that E is midpoint of AC and BD. But what is AC and BD? AC and BD are nothing but diagonal. So midpoint of diagonals AC and BD. From this result, what is our conclusion? That E is the midpoint. E is the midpoint of AC also and E is the midpoint of what? BD also. At this midpoint we know that this diagonal will get divided into equal part. Isn't it? Means E at this point E AC bisect what? BD, and at this point E BD bisect what? AC. Means we can say that AC and BD, these two diagonal bisect each other at point E. So this implies that diagonals AC and BD bisect each other at point E. So in this way, considering that the quadrilateral is what? Parallelogram. What we have proved? Diagonal bisect each other. Now we are considering second part. In a quadrilateral, if diagonal bisect each other, then we are going to prove that the quadrilateral is what? Parallelogram. So now conversely, suppose that let diagonals AC and BD bisect each other at point E. Now I am supposing that the diagonal bisect each other at point E. If the diagonal bisect each other, then we have to prove that quadrilateral is a parallelogram. So by midpoint formula, see what we will get. So therefore E is midpoint of AC and BD. If these diagonal bisect each other at point E, means E will be the midpoint of both the diagonal. So therefore by midpoint formula, see what we'll get. E bar is equal to, if I am considering that E is midpoint of AC, then E bar will be equals to A bar plus C bar upon 2. And if I am considering that E is midpoint of BD, then E bar will be equals to B bar plus D bar upon 2. So in this way we have got two values of E bar. So this implies that if you observe these two equations, left hand sides are equal, means we can say that these right hand sides are also equal. So A bar plus C bar upon 2 is equal to B bar plus D bar upon 2. From both sides, after cancelling 2, what we'll get? A bar plus C bar is equal to B bar plus D bar. So this implies that now I'm collecting, or we are arranging these terms so that we will get the sides of the parallelogram, sides of this quadrilateral. Keep B bar as it is, plus A bar on this side will become minus A bar. On this side C bar, keep it as it is, plus D bar on this side will become minus D bar. Just we are rearranging the term, we are using transformation here. Now C bar minus D bar, can I write it as DC bar? We know that dc bar in terms of position vector can be written as what? C bar minus d bar. In the same way, b bar minus a bar can be expressed as ba bar. Ba bar in terms of position vector can be written as what? B bar minus a bar. In the same way, b bar minus a bar can be expressed as what? AB bar. B bar minus a bar can be expressed as AB bar. Well, now observe these two sides very carefully. So whether both the sides are vectors, yes, both the sides are vector quantity, and both the vectors are what? Equal. If two vectors are equal, then our definition of equality of two vectors says that if two vectors are equal means their magnitudes are equal, means DC is equal to what? AB. DC will be equals to AB, and if two vectors are equal means they are in the same direction. If they are in the same direction means what is our conclusion? They are parallel to each other. Means DC is parallel to AB. DC is parallel to AB. So in quadrilateral ABCD, what result we have got? DC is equals to AB and DC is parallel to AB. And we know that in a quadrilateral, if one pair of opposite side is equal and parallel, check whether AB and DC are the pair of opposite side. DC and AB, yes, it is one pair of what? Opposite side. And in a quadrilateral, if one pair of opposite side is parallel and equal, at that time what is our conclusion? That quadrilateral is a parallelogram. So this implies that quadrilateral ABCD is parallelogram. So in this way we have got our required result. So now we are solving next example, question number 8. In this question number 8, we have to prove that the median of a trapezium is parallel to the parallel side of a trapezium and its length is half of the sum of parallel side. So first we will try to understand what is the meaning of median of a trapezium. So already you have studied about trapezium. When a quadrilateral is called as trapezium, if one pair of opposite side is what? Parallel. If a pair of opposite side is parallel. So in this case we have considered one trapezium ABCD such that AB is parallel to what? CD. AB is parallel to DC. So in here quadrilateral ABCD is trapezium. ABCD is trapezium, and since it is trapezium is definitely one pair of opposite side is parallel. So I am suppose here we have shown that AB is parallel to what? DC. Now try to understand what is meaning of median. Already we know that median of a triangle. Median of a triangle is what? Segment joining vertex and midpoint of opposite side. Three medians can be drawn in a triangle. But now we are discussing about what? Median of a trapezium. So median of a trapezium is nothing but a segment which joins the midpoint of non-parallel sides. So here which are the non-parallel side? AD and BC are the non-parallel side. So I am denoting here midpoint of AD is AD by E and midpoint of BC by F. Then segment joining this midpoint of non-parallel sides of a trapezium is called as median. So in this case this is nothing but your median. Okay. So what is the definition of median of a trapezium? Median of a trapezium is nothing but a segment joining what? Midpoint of non-parallel sides. So here we are supposing that E and F are midpoints of non-parallel side AD and BC. So therefore we can say that EF is median. Okay. So well, median is also known to us. Now what we have to prove? That median of a trapezium is parallel to parallel side. Which is the median now? EF. EF is parallel. We have to prove that this EF is parallel to parallel side. Means EF is parallel to parallel side. But which are the parallel side? AB and what? DC. Means we have to prove that EF is parallel to AB also and EF is parallel to DC also. Means we have to prove that these three segments are parallel to each other. Already AB and DC are parallel. If we are able to show that EF is parallel to AB, means indirectly we can say that EF is parallel to DC also. And what is the second result? and we have to prove that its length is half of the sum of parallel side. Means EF is equals to half the sum of parallel side. Which are the parallel side? AB and what? DC. So we have to prove that EF will be equals to half of AB plus DC. These are two our required result which we have to prove here. Hope the required result is clear to you. Now to prove these results we are using vector method, and vector method, to apply vector method, first we have to define the position vectors. So total how many points are there? 6. A, B, C, D, E and F. So let us define their position vector. Let A bar, B bar, C bar, D bar, E bar, F bar be the position vectors of points A, B, C, D, E and F respectively. So since here midpoints are there, E and F are what? Midpoints. So means we have to, somewhere we have to make the use of midpoint formula. So apply the midpoint formula. Therefore, by midpoint formula, see what result we will get. E is the midpoint. E is the midpoint of what? AD. So E bar will be equals to A bar plus D bar upon 2. And F is the midpoint of what? BC. So F bar will be equals to B bar plus C bar upon 2. F bar will be equals to B bar plus C bar upon 2. This result we have got applying midpoint formula. Now we will focus to our required result. In our required result, this is our required result. Now one of the side of this required result is what? EF. So now we are trying to find out value of EF bar. So now let us try to find out value of EF bar. EF bar in terms of position vector can be written as F bar minus E bar. So therefore EF bar will be equals to, so replace F bar by its value. What is the value of F bar? B bar plus C bar upon 2. B bar plus C bar upon 2 minus E bar will be equals to, E bar is equal to A bar plus D bar upon 2. Already the value of F bar and E bar is known to us. Applying what? Midpoint formula, just we have substituted these values. So therefore EF bar will be equals to, you will observe denominator of both the terms are same. Since denominators are same, that why we are taking subtraction of numerator. So what we'll get here? B bar plus C bar minus into A bar is minus A bar minus into D bar is minus D bar. So therefore EF bar will be equals to, EF bar is equals to, this half keep it as it is. This 1 by 2 half we are taking on one side. Now if you'll observe our required result, what is the first term? AB. So AB, so our result, available result is in terms of vector. So now to get AB bar here, which AB bar in terms of position vector can be expressed as what? B bar minus A bar. So means to get AB bar, we have to collect the terms of what? B bar minus A bar. So first we are collecting these two terms, B bar minus A bar. We know that B bar minus A bar can be expressed as what? AB bar. And later on, second required term is DC bar. DC bar means what? C bar minus D bar. Check whether here C bar is also available, minus D bar is also available. So just we are rearranging the term. Getting it? We have written the same terms, we have rearranged the term. So which is equal to half, keep it as it is. Now this B bar minus A bar can be replaced by AB bar, and C bar minus D bar can be replaced by what? DC bar. On this side, EF bar keep it as it is, EF bar as it is. Let us denote this result say by equation number first. Now if you observe this result very carefully, check that both the sides are what? Vector quantities, and both the sides are what? Equal also. And we know that if two vectors are equal, means their magnitudes are also what? Equal. Now we are considering only the magnitude. So this implies that EF is equals to, is it the magnitude of left hand side? So magnitude of EF bar will be equals to what? EF. And what is the magnitude of right hand side? Half of AB plus DC. So simply we have considered what? Magnitude. Since these vector quantities are equal, that's why we can say that magnitudes are also equal. In this way, we have got our one of the required result, isn't it? Now let us try to prove the second required result. Here we have to show that EF is parallel to AB. If EF is parallel to AB, and already AB is parallel to what? DC, means EF will be parallel to AB and DC. To prove this, again observe the given condition here. in this trapezium, AB is parallel to DC. If these two segments are parallel to each other, if two segments are parallel, means vector along these segments are also what? Parallel to each other. So since we can say that AB bar is parallel to what? DC bar. It is given to us that AB is parallel to DC, means vector along AB bar, vector along AB and DC are also parallel to each other. And we know that if two vectors are parallel, then one vector will be expressed as scalar multiple of another vector. So therefore, AB bar will be expressed as scalar. Let us denote the scalar say by K. So scalar multiple of DC bar, where K is scalar. K is what? Scalar. Now we are substituting the value of AB bar is equal to K times DC bar in equation number first. So put AB bar is equal to K times DC bar in equation first. Let us see what we'll get if we are substituting this value in equation number first. This is our equation number first. Keep this left hand side EF bar as it is. EF bar as it is. On this side, half also keep it as it is. Just simply this AB bar can be replaced by its new value. What is the value of AB bar? K times DC bar. K times DC bar plus DC bar, keep it as it is, plus DC bar as it is. So therefore EF bar will be equals to half, keep it as it is. If you will observe both the terms, DC bar, DC bar, if we are taking DC bar common from both the term, what we will get here? Here its coefficient is K and here nothing is in the coefficient, means 1 will be there. So now if you will just simply we have taken DC bar common from both the term. Now if you will observe this result, half is also scalar, scalar means real number, K is also scalar means it is also real number, addition of two real number is real number and multiplication of these two real number is also what? Real number. But in mathematics real number is called as what? Scalar. Means what result here we have got? EF bar is expressed as scalar multiple of DC bar, and we know that if one vector is expressed as scalar multiple of another, at that time two vectors are parallel. So therefore EF bar is expressed as scalar multiple of DC bar. And if one vector is expressed as scalar multiple of another vector, at that time we can say that these two vectors are parallel. So this implies that EF bar is parallel to DC bar. And we know that if two vectors are parallel, then the segment along which this vector lies are also what? Parallel. So this implies that EF is parallel to what? EF is parallel to DC. If vectors are parallel, means definitely these segments are also what? Parallel. But DC is parallel to. Now we have proved that EF is parallel to DC. But according to given condition, DC is parallel to what? AB. But DC is parallel to AB. This is given condition. Now what is our conclusion observing this result? AB is parallel to DC, but DC is parallel to AB, means we can say that these three segments are parallel to each other. So this implies that EF is parallel to DC and is parallel to AB. And this is the result which we have to prove. This is our one of the required result. So here we have shown that EF is what? Half of AB plus DC, and here we have shown that EF, AB and DC are parallel to each other. So in this way we have got our both the required results.